Bismillahirrahmanirrahim. Assalamualaikum and good day to everyone. My name is Muhammad Zazmizi bin Muhammad Alias, postgraduate student supervised by Dr. Rozidaini and Dr. Nick Raihan. Today, I will present to you about water treatment technology using adsorbent entitled The Efficiency of Bamboo Activated Carbon for Removal of COD from Fish Cracker Industry Wastewater via RSM. First, let me briefly walk you through important keywords that were used in this presentation. Activated carbon is a versatile absorbent manufactured from wide range of amorphous carbon-based materials. Activated carbon possesses high internal surface area, high degree porosity, and which contributes positively to its unique adsorptive properties. And for this study, carbon-based material chosen are bamboo and were carbonized into activated carbon for the COD removal. The COD is abbreviation for chemical oxygen demand, refer to the amount or quantity of oxygen required for chemical oxidation, such as decomposition of organic matter and the oxidation of inorganic chemicals. COD measurements are commonly made on samples of wastewater or natural water contaminated by domestic or industrial waste. RSM is a combination of mathematical and statistical techniques that we use to describe relationship between variables and optimize a system from several responses as well as different types of experimental runs. Now, for the study background, so the wastewater used in the study is came from fish cracker industry. The food industry discharged huge load of wastewater which came from kitchen cleaning and material preparation process into the environment, consequently lead to high biological and chemical oxygen demand value. Therefore, the absorption is one of the wastewater abatement suggests and is the one of the technology available in the market. It is a process where an adsorbent attracted to surface of an adsorbent with van der Waals force. So in the study, activated carbon as adsorbent recognized for its high internal surface area for effective adsorption capacity. Despite expensive costs on the production of activated carbon due to its raw material, research nowadays focus on producing activated carbon from agricultural residue such as old bamboo to solve the cost issue as well as solution to waste abundance in nature. The simple operation design and cost-effective option possess made adsorption a wise decision and often utilized as pre-treatment stage as stated in the literature preview. RSM is a combination of mathematical and statistical technique that could be used to approximate and optimize a system from several response and different types of experimental runs. For in this study, box banker design were used in the study and it is a popular experimental design as the design is able to reduce the number of experimental trials required to study interaction of multiple parameters and responses. So the objective in the study is to determine the performance of chemical activated carbon prepared from bamboo in removing the COD, chemical oxygen demand, from wastewater collected from fish cracker industry. Now we move on to material and methodology part. As we can see in the research flowchart, wastewater sampling were carried out in fish cracker premise located in Tumpat. Prior to that, activated carbon were prepared using bamboo as process stated in the flowchart. The old bamboos were collected from Agropark in UMK Jeli. The material was cut into smaller pieces using machine cutter and then were washed to remove impurities and further dry and oven for 1 day at 105 degrees Celsius. Next, the grinding and sieving process. The material was ground using grinder and was sieved to 1 and 2 millimeter particles using a siever. After that, for the activation process, the bamboo was soaked with zinc chloride. Zinc chloride is used as activating agent for the chemical activation process in the ratio of 1 to 3, and then the impregnated samples were carbonized in a furnace at 600 degrees Celsius with 1 hour holding time. And after the process, the activated carbon was washed with distilled water to remove excess activating agent present on the carbon surface. And last, the activated carbons were dried in oven overnight at 105 degrees Celsius. Back to the research flowchart. Next, the characterization of wastewater were conducted to investigate the water quality of the effluent, especially the COD. After the concentration of the effluent were acquired, stock solutions used in the study were prepared in 10, 30, and 50% solution. The utilization of concentration in terms of percentage is justified by feasibility to dilute the strength of the wastewater, as the wastewater do not have discrete numbers in terms of ppm or milligram per liter. Next, absorption study were carried out based on experimental run designed by RSM. Finally, the results obtained from the experimental run was recorded and the analysis were crunched using the RSM software. The result were calculated in terms of percentage removal, and this is the equation to calculate the removal. The percentage removal equal to initial concentration minus with final concentration in terms of ppm, and will divide by initial concentration times 100. For the experimental design, which were performed based on RSM method, three parameters named initial concentration, contact time, and carbon dosage were coded as A, B, and C, and the maximum and minimum value for the parameters were inserted into the box banker model. Generation using the software will give total of 17 experimental runs. The 12 factorial experiments were done with addition of 5 replication at the center point as displayed in the table. This one. So the absorption experimental design was performed using the standard response surface methodology design, which was box banker design via Design Expert software version 7.0 trial version. Now the results. The analysis of variance ANOVA illustrates that the model was significant in predicting the percentage removal of COD using the experimental condition study. From the experimental results, F value and P value of the model were 77.76 and less than 0.05 respectively, indicating the significance of the model with 0.01% chance that the model F value happened due to noise. In this case, A, C, A square, C square are significant model terms as the P value were less than 0.05. The validity of the model was justified by high value of R square value with 0.9901 and is in reasonable agreement with adjusted R square value of 0.9774. According to Al-Khatib et al. 2015, the model is better when the R square value is closer to unity, which stating that the theoretical value will be closer to experimental value for the response. The predictive model found for the percentage removal of COD is displayed as the equation stated. The positive sign in front of the term indicates a synergistic effect, whereas a negative sign indicates an antagonistic effect. Therefore, from the equation, we can predict that the increasing contact time and carbon dosage is expected to have better removal with lower initial concentration. The validation process was performed using the model's value for each variable to verify whether the model aligned with the experimental result. The experimental value obtained for the validation process was 71.63%, which gave a maximum error of plus minus 5% from the predicted response value of 70%, indicating the result's validity. Now, for the response surface plot, for the perimeter relationship, for the carbon dosage and the contact time, the removal was low at low carbon dosage and contact time. At lower carbon dosage of 0.1 gram, the percentage removal was 47.54% for 3 hours and 49.4% for 12 hours. At higher carbon dosage of 1 gram, the percentage removal was 73.62% for 3 hours and 74.96% for 12 hours. The COD removal increased with both dose and contact time. This is expected as at higher dose, more active sites available for absorption and longer time allow for longer interaction between active site and adsorbate for removal occurrence. At concentration of 10%, the percentage removal of COD at 3 hours and 12 hours was 68.2% and 77.27% respectively. At concentration of 50%, the percentage removal for 3 hours is 61.59% and for 12 hours is 65.57%. With concentration of 30% with contact time of 7.5 hours, The percentage removal obtained result within the range of 69 to 71%. There was no significant difference observed, but in meeting concentration with 7.5 hour contact time, higher percentage removals were achieved. And this were explained by Al-Hatib. The contact time is crucial in inspiration absorption equilibrium because a high percentage of COD was absorbed in early phase due to larger surface area available, but it gradually only a little removal occur when approaching equilibrium phase. This finding is supported by Thani claiming contact time is less important near equilibrium. Lastly, the carbon dosage again initial concentration. At lower concentration of 10%, the obtained removal for 0.1 gram and 1 gram were 51.45% and 76.53%. At higher concentration of 50%, the results were 40.62% and for 0.1 gram and 67.52% for 1 gram. Higher removal achieved when lower initial concentration with higher carbon dosage. This is because higher active site available to the lower number of particles to be absorbed. Now to the conclusion, the model was able to predict the experimental data with R-square of 0.9771 from equation acquired before. Increasing in contact time and carbon dosage is expected to have better removal with lower initial concentration, and this was proved by the validation test at the experimental value was achieved at 71.633% and in agreement with 70% predicted percentage removal. So therefore, chemical activated carbon prepared from bamboo was able to be utilized as a good absorbent in removing and reducing COD of wastewater from fish cracker industry. Reference. So the study would like to acknowledge the Ministry of Higher Education and University of Malaysia Kelantan for funding the project through NRGS grant led by Dr. Hafiz Jamaluddin. Thank you so much.